Hi everyone, I am Whit Roy. Today I invited electrical tutor Mark to review apprentice Sarah's remaining topics test paper. First, I will show all the test questions on the screen. You can have a try yourself. Then Mark will go through Sarah's paper. For each question, tutor will explain why the correct answer is right and why the other options are wrong. I hope you enjoy this style of learning. First, let's start this remaining topics test. 3, 2, 1, go. Now, let's review this remaining topics test. 3, 2, 1, go.
Question 63. Before carrying out insulation resistance testing, which actions are required?
Isolate the supply, make sure it's dead, and maybe disconnect equipment?
Yeah, that's right. Let's just walk through it slowly. When you do insulation resistance testing, you're actually applying a much higher voltage than normal to the circuit.
Oh, so it's not just like normal operation testing.
Nah, not at all. So if sensitive electronic equipment is still connected, that higher voltage can damage it.
Right, so that's why we disconnect it first.
Exactly. And then isolating the supply and confirming it's de-energized, that's just basic safety. You don't want anything live while doing that test.
Yeah, makes sense.
And that option about leaving loads connected, that's not what we want. It can give you misleading readings and also risk damaging equipment. Question 64. Which statements correctly describe insulation resistance testing?
I said high resistance means good insulation?
Yup, that's correct. Think of it like this. If the insulation is healthy, almost no current should leak between conductors.
So high resistance means very little leakage.
Exactly. Now, the reason we use a higher test voltage is to really check the insulation properly. If there's any weakness, it shows up under that higher voltage.
So it's kind of like stressing the insulation a bit.
Yeah, that's a good way to think about it. And it's not measuring normal load current. That's where some people get mixed up. Question 65. Which instrument is used to verify earth fault loop impedance?
I think I chose voltmeter.
Yeah, a lot of people go for that, but it's not right. This test is a bit more involved. What we're trying to check is whether enough fault current would flow if something went wrong.
So, like if active touches earth?
Exactly. And to do that properly, the tester has to simulate a condition and measure how the circuit responds.
So a normal meter can't really do that.
Nah, it doesn't give the full picture. That's why we use a dedicated loop impedance tester or a multifunction tester. Question 66. Which statements correctly describe polarity testing?
Making sure active is connected properly?
Yup, that's the key idea. Let's say a switch is wired in the neutral instead of the active.
Then when you turn it off, it might still be live.
Exactly. It looks off, but parts of the circuit can still be energized, which is dangerous.
So polarity testing makes sure switching happens on the active.
Yes, and that helps make the circuit safe to use. It's not about resistance or insulation, it's about correct connections. Question 70. Which factors may cause incorrect readings during electrical testing?
Loose connections and wrong range?
Yeah, both of those are big ones. If your connection isn't solid, the reading can jump around or show higher resistance than it should.
So wrong range just gives the wrong value.
Exactly. And faulty test leads can also throw everything off.
So it's not always the circuit. Sometimes it's just the test setup.
That's right. And calibration is actually a good thing, so that option isn't a problem. Question 78. Which statements are correct regarding use of a clamp meter?
Measures current without disconnecting the circuit?
Yup, that's the main advantage. You just clamp around the conductor.
How does it actually work, though?
Well, when current flows through a conductor, it creates a magnetic field around it. The clamp meter picks that up and converts it into a current reading.
Oh, okay, so it's not touching the conductor directly.
Exactly. That's why it's really handy and safer in a lot of situations. Question 69. Which conditions must be satisfied before live testing is performed?
I think risk assessment, PPE, and checking the instrument.
Yeah, that's right. Live testing isn't something you just jump into.
Yeah, I wasn't too sure about that one.
That's fair. You only do live testing when it's necessary, and when you do, you make sure everything is controlled. So you check the risks, wear the right PPE, and make sure your test gear is working properly.
So it's not like skipping safety steps.
Exactly. That option saying isolation is not required, that's not the right mindset. Isolation is always preferred unless you have a good reason not to. Question 70. Which statements correctly describe continuity testing?
Checking if conductors are connected?
Yep. More specifically, you're checking that there's a low resistance path.
So if resistance is high, something's wrong.
Exactly. Maybe a loose joint or broken conductor.
And it's important for earth conductors too.
Very important. You need a good earth path for protection to work properly. Question 71. Which statements correctly describe voltage testing?
Confirming supply and checking isolation?
Yes, you're basically asking, is it live or not?
So before and after isolation.
Exactly. Before isolation, you confirm it's live. After isolation, you confirm it's dead.
And you need the right instrument.
Yep, and it doesn't measure resistance. That's a different test. Question 72. Which actions ensure accuracy of electrical test instruments?
Calibration and checking before and after?
Yeah, that's right. Instruments can drift over time or get damaged.
So if we don't check, we might trust a wrong reading.
Exactly. So you verify before using it and again after just to be sure it hasn't failed during testing.
And storing it properly helps too.
Yep, looking after your tools is part of getting reliable results.
Question 73. Which statements correctly describe operation of a diode?
It lets current go one way and blocks the other?
Yeah, that's the main idea. A diode is basically used to control the direction of current.
So like a one-way device?
Exactly. When it's connected in the right direction, current flows. If you flip it, it blocks the current.
That part I'm okay with.
Good. Now, one detail people miss, when current flows through a diode, there's always a small voltage drop across it.
Oh, so it's not perfect.
Nah, not perfect. That's why that option is correct as well.
And the one saying it conducts both ways, that's just wrong.
Yep, that would defeat the whole purpose of a diode. Question 74. Which factors determine peak inverse voltage, or PIV, in a diode?
I wasn't very sure. I think I chose maximum reverse voltage.
Yeah, that's a good starting point. Think of PIV as the maximum voltage the diode can safely handle when it's blocking current.
So when it's reverse connected?
Exactly. Now, depending on the circuit and supply, that reverse voltage can change.
So design matters.
Yes, if the reverse voltage gets too high, the diode can break down and fail.
So it's more about protection than operation.
That's a good way to think about it.
And forward current doesn't really decide that.
Nah, different situation. Question 75. Which statements correctly describe full wave rectification?
It uses both halves of AC?
Yep, that's the key point. Instead of only using one half like half wave rectification, full wave uses both halves.
So output is smoother.
Yeah, smoother and more continuous. You don't get those big gaps.
And more output overall.
Exactly. Higher average DC value.
But it's still not perfectly smooth.
Right. There's still ripple there, so that pure DC option is not correct. Question 77. Which are correct functions of capacitors in rectifier circuits?
Smoothing the output?
Yep, let's picture it. When the voltage rises, the capacitor charges up. When the voltage drops, it releases that stored energy.
So it fills in the gaps.
Exactly. That's how it smooths the output.
So it also stores energy temporarily.
Yes, that's another correct point.
And it doesn't change frequency.
Correct. It just shapes the voltage, not the frequency. Question 78. Which conditions can produce transient voltages?
I picked switching and lightning.
Yep, both correct. Think about what those situations have in common.
Something sudden?
Exactly. When things change suddenly, like switching a circuit on or off, you can get voltage spikes.
And lightning is like a massive spike.
Yeah, a very big one. Also, sudden load changes can create similar effects.
So anything unstable can cause it.
That's a good way to see it. A stable supply doesn't create those spikes, so that option is not correct. Question 80. Which methods are used to protect circuits from transients?
Surge protection devices?
Yes, those are designed to handle sudden voltage spikes.
How do they actually work?
When a spike happens, they divert that extra energy away from the circuit, usually to earth.
So they protect the equipment.
Exactly. Varistors do something similar. They absorb or clamp the voltage.
And earthing helps too.
Yes, it gives a path for that energy to go safely.
So increasing load current doesn't really help at all.
Nah, that's unrelated. Question 81. Which statements correctly describe the MEN system?
Neutral is connected to Earth at the main switchboard.
Yeah, that's right. Let's just talk it through a bit. The idea of MEN is to link neutral and Earth at one point, usually the main switchboard.
So they're connected there, but not everywhere.
Exactly, just at that main point. Now, the reason for that is to make sure if something goes wrong, fault current has a solid path back.
So protection can actually operate.
Yep, that's the key. Without that path, faults might not clear properly.
So it helps safety.
Exactly. And it doesn't mean we don't need earthing anymore. That option is wrong. Question 82. What may happen if the neutral conductor is lost in a system?
I think voltage becomes uneven.
Yes, that's a really important one. When the neutral is lost, the balance of the system is affected.
So some loads might get too much voltage.
Exactly. Some parts can see higher voltage than they should, and others lower.
That could damage equipment.
Yep, very easily, especially sensitive appliances.
So it doesn't stay balanced.
Nah, definitely not. That's why that balanced voltage maintained option is wrong. Question 83. Which factors influence voltage drop in a circuit?
Current and cable length?
Yep, both correct. Let's just connect it clearly. If more current flows, you get more voltage drop along the conductor.
And longer cable means more resistance.
Exactly, so more drop again.
So both together make it worse.
Yes, that's why we consider both when designing circuits. Question 84. Which factors determine cable selection?
Current rating and installation conditions?
Yes, and also voltage drop. All three are important.
So it's not just, can it carry the current?
Exactly. You also think about how it's installed, like in insulation, underground, grouped cables, because that affects heating.
And voltage drop limits.
Yep, you don't want too much drop at the load.
And color doesn't matter.
Nah, that one's just there to distract you. Question 95. Which statements correctly describe different lighting types?
LEDs are more efficient.
Yep, that's one of the big advantages. They use less energy for the same light output.
And fluorescent needs control gear.
Yes, like a ballast. It helps control the current through the lamp.
So different lights behave differently.
Exactly. That's the key idea here. Question 96. Which conditions may lead to a stroboscopic effect?
Flickering light?
Yes. With AC supply, the light output can fluctuate slightly.
And that affects how moving objects look.
Exactly. It can make rotating machinery look like it's standing still or moving slowly.
That's actually dangerous.
Very, especially in workshops.
So it's not DC causing it.
Nah, DC is steady, so no flicker effect like that. Question 97. Which hazards are associated with working at height?
Falling and maybe electric shock?
Yes, both. When you're working at height, the risk is already higher because of the fall.
And if electrical work is involved, it's worse.
Exactly. You've got multiple risks at the same time.
So it's not just one hazard.
No, you have to think about the whole situation. Question 98. Which safety practices apply when using ladders?
Make sure it's stable and at the right angle.
Yes, if the ladder isn't secure, it can slip or tip.
So base and angle matter.
Exactly. Also, making sure it's on firm ground and positioned properly.
So it's all about stability.
Yep, that's the key idea. Question 89. Which statements correctly describe safe isolation procedures?
Isolate, test, and lock and tag?
Yes, that's the full process.
So why all 3 steps though?
Well, isolating removes the supply, testing confirms it's actually dead, locking and tagging stops someone else from turning it back on.
So each step covers a different risk.
Exactly. If you skip one, there's a gap.
So live work isn't the normal approach.
No, isolation is always the safer option. Question 90. A 3-phase motor loses 1 phase during operation. What happens?
Current increases, torque drops, and it overheats?
Yep, that's a really good answer. Let's just connect it. When 1 phase is lost, the motor still tries to run.
But it doesn't have full supply.
Exactly. So the remaining phases carry more current.
That causes heating.
Yes, and at the same time, the motor can't produce the same torque.
So performance drops and damage risk goes up.
Exactly. That's why it's such a serious condition.
Yeah, I can see now this part is not really about memorizing definitions.
Nah, not at all. It's more about understanding what happens in real situations.
Like what changes and what the result is.
Exactly. That's what the exam is checking. If you understand how things behave, you can work out the answer even if the wording changes.
Yeah, I feel a lot more confident now.
Good, that's what we want. Keep thinking in that way and your marks will move up quite quickly.